All right, so before you folks jump into the video, I just want to clarify a couple of things. Firstly, the output at the end of the chatbot is kind of different than what I had expected. So what actually happened is it did work as as I intended to, but the output kind of starts responding endlessly. So you can see when I asked a question, what is this PDF about? The PDF appears to be a collection of news and announcement from OpenAI. So it does respond to the questions that you ask to the model, but weirdly it kind of endlessly answers the questions until it hits the token limit. So you can see it starts a new chain, end of token ID, and then it starts a new chain and it kind of goes on responding to its own question. So it start asking its own questions, responds to its own question. It kind of keeps on going, especially if you don't have context limit in place. So what I did is I did some research and I understood how you can limit the responses in the chatbot, and you can add something like num predict 50, which will limit it to 50 tokens. But even so, it did respond endlessly till it completed 50 tokens. So again, it's not like the chatbot didn't work. Everything worked. The model was mounted, it was running, it's responding. It's just that the response appears to be like this. And if you know the solution for something like this, please drop in the comment. I'm anyways going to invest some time and do some research with respect to how I can fix this. I was kind of hesitant to post this video because the endless response is not most people are looking for. But regardless of that, I did kind of walk through a bunch of different concepts in this video, and I just wanted to share it across for people who, regardless of Llama 3, want to build like a RAG chatbot. And like if I can figure out a fix in the future, I'm gonna drop a note on that as well. So I just wanted to give that disclaimer for, most people may not be expecting like an endless response, they would probably be expecting like a proper chatbot. So I just wanted to clarify that, and I'll also share the code that I've used here, so no need to worry about that. Either ways, I hope things are now clear. Let's get started. Hey folks, so we all know Llama 3 went live a few days back and almost everyone on YouTube is talking about it, right? And in this video, I'm going to be walking you through how you can build a local chat PDF chatbot using Llama 3. So a couple of weeks back, in fact, I uploaded a video on RAG, which is like a complete RAG masterclass that covers what is RAG, how it works, the architecture, and so on, mostly for non-technical and even for technical folks. And then what we do in the tutorial itself is we build a chatbot, Streamlit Power chatbot, that allows you to chat with the document. So you can see the chatbot here. So you ask a question and then the local model answers the questions for you. Again, this is powered completely locally. We are not using any paid API like Claude or OpenAI or so on. So the context here is that what I'm going to be doing, I'm using the same code that I wrote here. And instead of using Llama 2 in the tutorial, so if you look at the code here, you would notice that I'm using Llama 2. But what we will be doing instead is we'll be using Llama 3 for it. So mostly this tutorial is going to be very, very short, primarily because everything you need to know about the code is already covered. Either ways, I'm going to give you some high level with respect to what means what inside of the code, so that you get like a complete overview of, or at least like a high level overview of what we are doing here, right? So what we are going to be using is LLama for this. So open a new tab, go to LLama. LLama is basically a framework that allows you to run these large language open source models. So if you click on the models here, you will find it literally has every new model that was released of late. Mistral's latest release, Wizard LM2, Gemma, Llama 2, and even Llama 3. So we'll be using this, and it's very easy to set up. Just click on download here and then download for whichever OS you want. I downloaded for Mac, and once you download, you will be able to find the LLama command. You will be able to type LLama in your application, after which you'll be able to see the LLama icon here, which basically means the model is running. Now we will go inside of the models, and here you need to choose Llama 3, and then in Llama 3 you need to copy this command. So there are two things here. If you are looking for a 70 billion variant, and let's look at the Llama 3 paper, there are two variants Llama comes with. The first variant is the 8 billion parameter, and the second variant is the 70 billion parameter. The 8 billion parameter variant is better than Gemma and Mistral, but it's also relatively lighter. The 70 billion one is 40 GB. So unless you have like a very clear use case with respect to, if you're using it for smaller use cases, for example, talk to PDF and stuff, then 7 billion or 8 billion parameter is fine. But if you're using it for production based use cases, where you want to serve your customers and so on, then maybe 70 billion one is the ideal one for you. Again, look at what you're looking for. So let's say you're using Gemini Pro 1.5 and you want to replace with Llama 3, then you should probably use the 70 billion parameter model. But anyways, for us, we'll be using the smaller model because this is just a tutorial. And if you are not familiar with how Python or code in general works, you basically need to download a couple of things. You need to download Python. This is the very first thing. And once you download Python, you also need Visual Studio Code. So go ahead and download the Visual Studio Code as well, depending on the OS you have. Visual Studio Code is an ecosystem where you will be able to write the code. So in this scenario, this is where we want to write and run. And Visual Studio Code, VS Code, kind of allows us to do that. So anyways, I'm hoping that even if you kind of feel that this is too hard for you, just go to this tutorial and follow along. You will be able to reach a point where you have all of this in place. Instead of Llama 2 there, you can use Llama 3 so that you don't have to watch this video again. So let's quickly go through what we've done here. And let me just walk you through what is what here. So firstly, we created an environment, virtual environment. And that's primarily because I wanted to install all of these libraries inside of that environment. Again, all of the environment setup will be taught to you in the video itself. But basically what virtual environments allow you to do. So you can see there are a bunch of different things we are also using here, which is LangChain, Streamlit, and yeah, I think pretty much those two libraries. Now, when you install Python, it will not have all of this, right? So think of this as you buying a smartphone. It will only come with some apps that will do A, B, C. But if you want to do more, then you want to add more apps. These are those more apps. So LangChain is a library, and this is something that you can read about here. If you go to LangChain, it's basically a library for Python and a bunch of different programming languages where you can build RAG-based use cases. So it kind of simplifies a lot of these things that you would otherwise do manually for these use cases, right? So you would see that we would create like a prompt template, conversation buffer, we would do embeddings, and then we would also kind of break down PDF into smaller characters, so recursive character text splitter, and so on and so forth. So the LangChain library allows us to kind of, minimize the use of that code because someone has already written the logic to break down the document into smaller chunks. We don't have to manually write it, which is why a bunch of different things that you would do typically without a library like LangChain has already encapsulated all of that and made it easier for you to run this on your system. So either ways, go ahead and do two things. Once you do environment setup, you'll have to also install libraries like LangChain and Streamlit. Now I've already installed this, so it's not going to reinstall it for me. But go ahead and do it in your case. And again, like I said, follow that tutorial because it will give you most of what you need to know. Next, what we do is we create two folders. We create a PDF files folder where we will store the PDF file. And then we create a vector.db folder where we will store the vector.db file. So I'm going to be deleting both of these because we want to start from relatively scratch when it comes to PDFs. Next, what we do is we create a prompt template where what we have is that we give some information with respect to, so if you know custom instructions, this is similar to that. So you'll say you are a knowledgeable chatbot here to help with questions of the user. Your tone should be professional and informative, and then context and history is what you would feed to the user. For it to answer questions like ChatGPT or any chatbot, you need to also have some context with respect to what the user is asking, some history with respect to what already has been discussed, and then the actual question of the user. So when you are feeding something on ChatGPT, you have three of these details. It automatically kind of fetches that, right? So when you ask a new question, it will refer to see if there was a previous chat. If there wasn't any chat, then it's going to start from fresh. But if there was some context, it will respond to you in a way that is related to what it responded previously. So ensure that, again, all of this, I have this code written in a Google Doc. I'll add the link to Google Doc as well in the description. So again, I'm going to just explain it to you if you don't want to spend your entire time there and rather get a high level because you might already know all this. And then we create the actual prompt that will be sent to the prompt template. Then we'll create a memory that will mean, some bit of the history of the chat, right? So you can see this is the history, and we want to maintain the history just so that the responses that the chatbot is generating is related to what the chatbot answered previously as well. Now we will create a vector store, or basically embeddings. Embeddings are basically, think of them as smaller details of documents, a summary of documents, such that if you ask a question about page 100, what the embeddings allow models to do is go into that relevant part easily. Other than, it's not going to look for from all the 100 parts. If you have 100 parts of the document and you have some data in the 50th part of the document, then these embeddings allow models to figure out, okay, it's in the 50th. And it uses some sort of probability for us to identify where these parts are. So that's how kind of embedding works. And let me just open up terminal for 1 second and do OLLama run LLama-3, because I remember installing this before, and I just want to ensure that you do this while you're going through the code. So after you install Llama, go into your terminal and run this command. So if you not downloaded the model yet, while I'm going through the code or you're writing the code, this will be downloaded in the backend. And by the time you come back to this or are ready with the code, this will already be ready. So I'm going to do buy to stop this because I've already downloaded it. So let's change this to Llama-3, and let's also change here to Llama-3. Okay, so this was the embeddings where you give some probability with respect to where the question can be most likely answered that is asked by the user. So when you upload a PDF, there are 100 pages, and if there is answer in the 10th page, this all embeddings allow models to figure out if it's in 10th page or not. And then there is the LLM, which is the actual model that you will use to chat. So you also need an LLM, which is what we'll use here, again Llama-3. And you can see we're using a base URL like this. Let me explain what this is as well. So if you go to the documentation here, you can see every time after you install this and you're running it here, it basically is serving your response, or you can also use this as an API locally on this HTTP address, right? So if you've been a developer, you know what I mean. So if you're not a developer, then when you see the URL like this, right? So when you type ollama.com, it goes to a location or a web page where the data is available. Similarly, when you install OLLama, it allows you to run the models on a specific local location. So no one outside can access this for you, but inside your computer, there is a location where this code is running. This is that location, and that's what we're passing here, that whenever you want to ask a question, go to this base URL, because that's where the user is, or that's where the model is available for you to answer these questions. So this is mostly, with the basics of setup. Then you also set up the chat history that will maintain everything that the user is talking about. And I've spoken in depth with respect to each of these in the actual tutorial. So go ahead and check that out if you really want to deep dive into this and if you don't understand this. And I'm going to call this one Llama-3 chatbot. So then we have the Streamlit title, which is the title of the app, and then uploaded file will be basically a way for user to upload something. So we will have a file uploader here in place, and then we basically write the logic for breaking down the text. So before that, we actually do maintain a chat history that will show the role and the message. And let me kind of go back to tutorial to show you what I mean. All right, so I think this will be more clear now. Instead of PDF chatbot, what we will use is Llama-3 chatbot to talk to PDFs, and then this is the file uploader that I added here. And then inside post this, there is like a chat you see here, right? So there is the role, which is this is the face of the role, and then there is the message. So role and message in the same line. So when the role is user, you will see this. When the role is machine, you will see this. So that's how it is. And now the UI is mostly done, right? And because this is a list of sorts, this is going to show it in this format, right? Just like a chat would appear or ChatGPT would appear. Now, if the uploaded file is not none, which if the uploaded file is not empty, you show something like file uploaded successfully, and you can see the message here. And at the same time, move that file to PDF files, which folder we just deleted at the start of this, and show the status showing saving file. Then we do basically do processing by opening the PDF file and ensuring that we format it well. So we will then initialize the text splitter, which will break it down into the chunk size of 1500 characters, because this is the recursive character splitter, and then which will have the overlap of 200. So let's say if I want to kind of break down a 100 character word into something, into say, or maybe 1000 character word into 10 parts, the first part will not have context about the previous part because it's the first part, but the second part should have some context with respect to what the first part is and what the third part is. So that will enable the model to give better responses because it will have a longer context window. And it also will have some information about the previous part. So if a model is referring 2 or 3 parts at once, it will know how to connect each of these parts better. and then we will, split it down and store it into our vector database. Vector databases are basically, like I said, when you break down these chunks into smaller parts, you will need to store it somewhere. And this is where vector databases come in, that will store your parts and probabilities of how likely that specific answer is in that specific part, right? So again, like I said, it's just going to store your parts. And again, like I said, we will be using Llama-3 for this. Now, mostly it's on the lines of the question. Okay, so this one I think is something that I want to talk about. So there is the retrieval QA, and this is where we are feeding all the things that we created, right? So every time a new chat starts, initiate a session state with retrieval QA, where LLM is what we set up here. The chain type is stuff, which is again a LangChain method. You can go ahead and read it up. Retriever is the retriever that we created here, which basically means that we get data from the vector store. Verbose is true. This will allow us to kind of see what is happening in the UI here or terminal here. And then prompt is the prompt that we created here. Again, memory is the memory that we created here. So now basically what we're doing is every time user starts a chat, all of this happens. Again, all of this is explained in the previous video. So if you don't understand this, just, you know where to kind of read about all this. So if the user is adding the message, then this appears as the user message basically, right? So we're just breaking down the role of the user and the role of the machine. And you can see there is the second role here is the assistant. And whenever the assistant is typing, show assistant is typing, and in the meantime, do all what we created here, right? So basically, again, what we are doing is that we're creating a chatbot where we have two components, the user and the assistant. Both of these have different flows. So when a user says something, the assistant needs to show that he's typing something, which basically is assistant is typing, and then do the QA chain, which is this, right? So run this. After the user says something, run the machine, and when the machine is initiated, run this, which will in fact run all of what we created before. So this is just like a workflow. And then when there is nothing, the user has not uploaded a file or nothing, then you just show, please upload a PDF to start the chat or chatbot. All right, so again, if you don't understand this, go back to the video that I referred, and I think most of the questions that you have will be cleared. Now, in order to run this, what we can do is streamlit run app, and you can see it started a new window like this, and this is the Llama-3 chatbot. Now I'm going to see if it's working. So let's just quickly check. So I'm uploading the file now, and it's definitely uploading the file. Let's just quickly check the terminal to see if there's something happening there. You can see as I upload the file, there are two folders created, the PDF files and the vector DB. And the file is successfully uploaded, which means we can start typing now. What is this doc? So if this is working well, you can see the model is generating the response, and we're using Llama-3 here. So you can see the response is generated in terminal, but you don't see that here yet because this only works after the response is generated. Let's just wait for it to complete. I'm gonna keep this here. Oh, okay. Seems to have gotten into a endless flow of chat. Is this the Llama-3 bug? This is interesting. I've not seen this behavior before. We got our answer when we wanted, but then it just started talking to itself. Am I working with an AGI here? Oh man, I can't even directly stop this. So again, it seems we've run into the bug, so we probably have to redo this. Very interesting. It's still going, by the way. Okay, so it finally did finish the chat. And because we stopped it, it's not working. But you can see we ran into a very weird bug here. I don't know how to report it because this is not what I expected as the response. So you know what, we'll just go ahead and delete both of this again and try it. Sometimes local models can run into problems like these because as opposed to a paid model that have guardrails in place, meaning they have a context window post which they will stop responding. In most cases, we don't do that sort of setup here. So you can see we've not kind of specified the context length here, meaning we don't have a window with respect to when to stop responding. And I'll have to look up what to use in order to kind of define how long your response should be. But because we don't have that here, models can keep going until for a very long time, and we just saw that, right? Either ways, let's try it again. You can see we're doing the exact same thing. You can see the PDF file is uploaded. The vector DB is still empty, meaning we are still processing this. It's still empty. I don't know why it's showing saving file. Oh, it's showing saving file. Let's just wait for a few seconds for it to add the vector db here, because this has a bunch of different pages. It can take some time sometimes to work. All right, it seems it worked. Okay, so it did work. And now what we will do is we will type the question again. What is OpenAI? Let's look at the terminal and hope it does not continue and respond endlessly. It's working as expected. My gut says that this might be using its own memory. It's still going on, like it's continuing to respond endlessly. So we'll probably have to define a point where it stops responding. So let me quickly kind of look up the documentation for Olama LangChain here. So as the temporary solution, I was able to figure something out. You can see the number predict, meaning the num predict here. If you mention this as 50, which is basically the context window in which it should respond, then it's going to be responding in a more relatively limited manner. But you can see there is still EOT ID and start header ID and a bunch of different things that we don't want. But if you use numPredict, it's going to stop that. So I'm actually trying to figure out how we can stop it from endlessly responding. And again, all of this depends on model to model. So I used to use Llama 2 here, which did not respond endlessly. But if you use, it's apparently now responding endlessly. So we'll probably have to define some end state. So let's say if this is what you see, EOT ID, then the model should stop responding basically. So I'm going to be spending some time to figure out how I can stop it from endlessly responding, and I'll drop a note in the channel posts and also update the documentation with this. It's probably related to Llama 3 somehow, and I'll probably have to do some more reading with respect to how to stop it. But for now, you can use numPredict, which will stop it after 50 tokens, which is what we want at this point of time. So cool. Thank you so much, guys. I hope you learned something through this, and I will see you guys in the next one.